Okay, what we're going to do now is finding congruent angles, and this means we're going to show how you can prove that two angles are the same so that you can then prove similarity. Now the word congruent, that's new to most of you. Congruent just means the same. Okay, so we're finding two angles that are the same. All right, now luckily you've actually already learned all these rules. We did them in the first year, so none of this should be super new to you, and we're going to go quickly over the rules for showing congruency. Okay, the first is if we have line 1 here, line 2 here. Okay, these lines are two straight lines that continue. Okay, they are not they do not bend in the middle. Okay, you can see that they continue through this the whole way the same. Okay, now this angle here is the same as this angle here. Okay, and this is what we call vertically opposite angles. So vertically opposite angles are congruent. We're going to try and use the right words now. Sorry, I will forget sometimes. Vertically opposite angles are congruent. That is the first rule. So when you're looking for this rule, what you want to look for is the shape of an X. Okay, this is an X shape, and in the X shape, the opposite angles are congruent. We can just say opposite also. I don't care about the vertically, but that is what is quite often used. All right, this also means that these ones are also congruent. It doesn't really matter which way you look at it. Okay, so that's rule 1. You guys have learned this before. All right, rule 2. If we have, oh, we didn't want that to be red. Can I change it to black? Yes. If we have a set of parallel lines, let's hope that these are actually parallel. Now, when we have a line that intersects these lines, this is called a transversal. Okay, whoops, we want this to be black. This line here is called a transversal. The name is not really that important, but it's good for you guys to get exposed to it. Transversal is because it transverses the other lines, it crosses them. Okay, these guys are parallel. When you have a transversal on a set of parallel lines, we have a few different rules that we can use. 2 of them to be precise. So we're going to talk about those now. So the first rule, when you have parallel lines and a transversal, is, let's use a different color for some fun, this rule here. Okay, and you can see that we have here an F. All right, when you have an F, when you can see an F, the angles that are involved are these two underneath, and those two angles are the same. We use the word corresponding to refer to these. So corresponding angles are congruent. Okay, so corresponding angles are congruent. Those two angles there are the same. Now, this F doesn't have to be in this particular orientation. We're going to do a couple of little smaller versions of this just to show some different orientations that we can have. So you can have this orientation. We have 4. So there's the one that we already did. And then we're going to have some little guys just to show you some different ways that you can find that F. Okay, you can also find the F backwards. So this is also an F. This is also corresponding. And guys, you need to write corresponding as your rule. I don't want to see F. Learning English, learning maths is also about the language that you use. You can also have your F upside down, so it can be like this. And in this case, these two angles would be the same. Okay, these guys are also corresponding. And then we can also have an upside down backwards one. Okay, so these two angles are also corresponding. So if you're looking for two angles that are the same, this is another way that you can find them. So these are corresponding angles. The third rule I'm going to do here. Hopefully you guys remember this one as well. Let's use purple this time. And this is this rule here. Okay, it looks like a Z. When you have a Z, these angles here are congruent. So we say here that alternating or alternate angles are congruent. Okay, and alternate, if you alternate something, it means that you've swapped it. Okay, and you can see that the angle swaps from one side of the transversal to the other side. That's why we call it alternate angles. So alternate angles are congruent. And again, there are a couple of different ways that we can draw this one. So you can have the Z that we've already drawn. You can also have, whoops, you can also have this Z like this, in which case these two are equal. Okay, so these two angles are also congruent. All right, so those are our three rules. What this means is that if you get a triangle, a set of triangles, you can look for vertically opposite, corresponding, and alternate angles in place of just the shared or given angles. Okay, so these are new situations that you can look for. What we will do is we're going to do just the example that's in the book, because I don't want to spoil, there's not so many questions for all of this, and I don't want to spoil it by doing a question that, it wastes question opportunities if I do them all. So I'm going to see if I can draw it like this. Does it work? No. Okay. So we have this triangle, and then we have this triangle. Let's pretend that I drew that properly. Clearly I didn't. Maybe I can, no, I can't rotate it. Okay. Anyway, let's pretend that I drew this properly. In my picture, these guys are parallel in theory. Actually, I am going to redraw this because I don't like it. So let's instead use this. Oh. Then I know that the lines are straight. Okay, and I'm going to draw one like this. And one like this. I still forget to use that line every time. Okay, so we're going to say that in our diagram, these two are parallel. Okay, we have a measurement of 3.2 here. We have 3.4 here. We have 5.2 here. And we have 5.8 down here at the bottom. Our letters are going to be DSR. And then PQ. Now you'll see in the book they've also put a 1 here and a 2 here, and they refer to this as R1 and R2. That's fine, except that in the future you're going to have to use the 3-letter rule anyway. So I prefer for you guys to just learn it properly from the start instead of learning shortcuts. If you learn the shortcut, then you have to unlearn it later. So I'd rather just teach it properly. It's not like it's difficult. Okay, now we want to know the value of RS, and I always find it nice to write it down somewhere, and RT. Okay, so these are the two sides that we want to find. I'm going to just move them so I can make my PDF later. So these are the two sides that we want to find. And you need to now think about what are we going to do to show this. So the first thing you need to do is, of course, we're going to use similarity because that's what this whole topic is about. So the first thing you're going to need to do is do a similarity proof. Now, what rules can we use for this? You need to now look at these two triangles. It's pretty clear which triangles we're going to be working with. So it will be triangle RST and triangle PQR, we're going to look at these two triangles and we're going to see what can I do to show similarity between them. Hopefully you've already noticed, and as I said to you, please use colors for this because it will help you with identifying things later. Hopefully you've already noticed that we have here vertically opposite. I'm going to color it in nicely here. Doesn't matter what the size of them is, we know that it's the same. So these two angles are the same. So we're going to start with that angle. Now the top one, it's going to be from the top down and up, TRS. Or as I said in the book, I think it refers to it as R2. Yeah, you can do better than that. Is equal to angle PRQ. And that little, this little thing I'm writing means angle. I hope you've realized that by now. So angle TRS is equal to PRQ, and as I said, we always must write a geometrical reason afterwards. In this case, the geometrical reason is opposite. Please don't write a sentence or a story. I just want a word, and in this case, the word is opposite. All right, that's our first angle. So we've now got to look for another one. Hopefully you've realized that we have two parallel lines and a transversal. Oh, and I've just given away what's happening here. We have our parallel lines and our transversal, but we also have a transversal going the other way. You can also go this way, but you can also very clearly then see what rule we're going to use now, and that's the Z rule. Okay, and the Z rule is alternate. So we can show, and again, use colors because it helps you. You can show that angle S here, I'm just going to put a little squiggly star in purple, is the same as angle P here. Be careful because some people think it's Q. So now we can say angle TSR is equal to angle QPR. And the reason for that is this was the Z, which means that it is alternate. And again, if you write Z here, I am going to give you 0 points for this proof. You must write this properly. Okay, so we have shown that two angles are the same, therefore the third ones must be the same. You can color that in as well if you like, but it's not necessary. So we can now say therefore, the 3 dots, remember, means therefore, triangle. We had RST is similar to, with this is similar to S, triangle. And now again we need to be careful about which the order of how we label our angles here. Now point R was first and R is the same in both triangles, so we're going to start with R again. The next point was point S. Okay, we went from blue to purple. Purple is S, so purple is P, so we're going to put P here. And T is obviously then Q, the two empty ones. So we've now done our proof. Fantastic. This is our proof. Just turn my computer and write that down. Whoops. Proof. So we have our proof of similarity here. Now that we've done that, we can use a ratio table to find what we're missing. So ratio table, start by always putting the letters in. So we had RST, so RS, ST, and then what's left is TR, or RT. Okay, in the second triangle then, the equivalent of RS should be the first 2 letters in our proof, but RS was from blue to purple, so that's blue to purple in the second triangle, which means RP. ST is purple to nothing, and purple to nothing in the bottom triangle is P to Q. And RT is blue to nothing, which in the second triangle, blue to nothing is RQ. Okay, so now we fill in what we know. We know RS, actually we don't know RS, and that was what we were told up here at the top that we were going to find. So RS I'm going to put in as X. Okay, ST is 3.2. RT we also don't know, and RT was also what we had to find up here, so we're going to put that in as Y. It's not the same as RS, so we need to give it a new letter. All right, RP we have, that's 3.4. PQ is 5.8, and RQ is 5.2. Now, you've made your ratio table, you've done your proof. Now we can just use cross multiplication to find what we need. So we have here 5.8x is equal to 3.4 times 3.2. So 5.8x is equal to 3.4 times 3.2, which is 10.88. Okay, x is going to be 10.88 divided by 5.8, which is, well, we're going to say approximately 1.88, rounded to 2 decimal places. And, oh, the question said to 1 decimal place, so in this case it would be 1.9. Okay, so we found x. Now we want to find y. We're going to do the same thing. So for y, we're going to cross multiply here. Don't use the x that you just found because the x was not accurate, or keep it as a fraction if you're going to insist on using x. So 5.8 y is equal to 5.2 times 3.2. So 5.8 y is equal to 16.64. Y is equal to 16.64 divided by 5.8, and that is 2.9, and that was approximately. Now, it's also important here that you actually go through and write these steps out. I don't want you to just see you using the ratio table method that you've been taught in history of times and then divide. I want to see the algebra behind it, because you're not always going to get ones that can be done just like this. For example, the one that we did in the last video, or did we do it up here? No, in the last video, we did one where it had x plus something, and you can't use that physics method of just doing times and divide in order to do this. And I don't want you in that habit. I want to see the algebra behind what you're doing, not just the answer. You guys know the answer doesn't matter. All right, so this is how to find congruent angles and how to then work with them. Hopefully you're getting a bit of an idea of how similarity works now, and you'll be able to work through your questions. So good luck.